now that we've loaded our data frame, it's time to start asking some questions. And the first questions we want to ask, which is already quite interesting, is we want to find out what are the essential genes, what are the most important genes in the breast and the myeloid cancers that we've got the data for. And when I did it, I didn't know what the answer to this will be, and it gives you quite interesting insights immediately. Well, that could tell you, okay, these are was targeting, these are genes was targeting for these particular cancers. Um, so in order to do this, so right now we have the data frame with all the data. So we need to process this data step by step to get to our answer. The first thing is we have to isolate just the breast cancer data and the myeloid cancer data. So separate those two using filtering. Then we have to calculate the mean gene effects across all the genes and then sort to find the smallest value. So the smaller, the more essential the gene, remember? So we need to sort from the lowest to the highest and find the top 10. And then do the same for myeloid cancer. And then we can compare the top 10 essential genes in myeloid and in breast cancer. So this sounds quite simple. Uh, and this will be a good example of going through a pipeline working with pandas. So we'll do that now. I'll show you the code from the beginning, how this looks like, and then we go through the individual steps in a little bit more detail, and then practice them more in the labs later. So as always, first we import pandas as PD, and then we load the data from the repository here via the URL that I've given you here. And that gives us our trusted data set with the myeloid and breast cancer data. So as I said, first we have to isolate the cancer data. And for this, we have to use a Boolean filter. So we'll talk about this in a minute, but it is basically we're telling here the pandas, give us just the data where the oncotree lineage equals breast. So this is actually quite a simple uh, formulation that makes sense immediately if you read it. So we want from the DF, we want to have the DF where the oncotree lineage is breast. And that will separate out just the breast data. So this is what we want here. And then we have to take this and then isolate just the numerical values, so just the gene names. So for this, there's different ways of doing that. But for example, we know that the genes start with column 6. So we select all the columns from the 6th onwards, and then filter the breast cancer data again with this list of columns, with all the gene columns. And we can then immediately ask, get the mean of that using the dot mean method. And that will print us out the mean. This looks actually then, this breast gene means like a single, so this transverses the data, then the genes are listed as rows, and it gives us the means of the mean values of each gene. So now we are nearly there. We have got what we want, but we just need to sort them. So you need to learn one more command here, which is the dot sort values command. So we've take this list, these rows of values, and now we want to find what is the most essential one, and then just give me the top 10 most essential ones. So we can do that here. We say sort the value ascending true, and that will give us the whole row of the 17,000 genes from the lowest to the highest. And if we say dot head, it will give us the first 5, but if we say dot head and then inside 10, it gives us the top 10 of those genes, which are the most essential genes. And then this is just some fancy print statement to print it out nicely. But in the end, we just get the list of the top 10 genes and their essentiality values here. So you see that the gene RAN, for example, is the most essential gene in breast cancer. And this, when we compare this to myeloid cancer, which we'll do in a minute, this will be quite informative to see how does the dependency spectrum differ between these two cancer types.